So we can discuss things that give rise to greater virulence. And so that previously our list we talked about things that give rise to lower virulence or can have the impact of reducing the likelihood of evolution towards higher virulence. These instead would be things that can give rise to a greater likelihood of evolution towards higher virulence. So one of these things is if there are in fact no constraints on the evolution of higher levels of virulence. So one example of this, if there is a lack of correlation between the virulence displayed by a parasite and the transmission of that parasite. If you could vary the virulence all over the place and it has no impact whatsoever on parasite transmission, then there is not going to be anything, at least in terms of transmission rates, that limits the evolution of ever higher virulence. Remember that we have an expectation that within population selection will tend to select for higher virulent parasites. That is, within host selection will tend to select for those parasites that can replicate faster because they'll end up making up a larger proportion of the individuals within a given host that in fact will be transmitting. And if there is no impact on the potential for these parasites to be transmitted because they're increasing their numbers faster, then you're not going to have constraints on the evolution of greater virulence. You can take this one step further. There's the possibility that there's actually a positive correlation between parasite replication rates and parasites transmission. So if those parasites that in fact are replicating faster also end up being able to be transmitted at a higher rate, then you would expect selection not just within the host for a higher replication rate and thereby potentially a higher level of virulence, but also for the transmission step to select for those individuals that display a higher level of virulence. In a sense, this is the opposite of antagonistic pleiotropy. It's more of a positive pleiotropy where you have the increase in growth rate being also associated with an increase in rate of transmission. And if it's the same allele that's giving rise to both, that is a pleiotropy. It's two phenotypes affected by a single gene, but in this case they're not in antagonism with each other, but instead are in fact correlated where both are increasing in functionality. You can also have a lack of bottlenecking at the start of infections. If infections are not clonal, if they're started with numerous individuals, then you potentially will have a substantial amount of genetic variation from the start, and you would have an expectation that those individuals that are able to replicate faster within these hosts that are started with multiple individuals will be the ones that come to dominate those populations, and therefore they'll dominate among those individuals that are being transmitted. So the result, the result is that you have infections consisting of multiple parasite genotypes, and when you have multiple parasite genotypes, you have an expectation that there's going to be competition between those parasites and natural selection on those individuals that are fit. In this case, in terms of their potential to replicate faster, thereby potentially giving rise to a higher level of virulence. You can also have infections last sufficiently long that there is accumulation of mutations and selection on that resulting genetic variance. And as a consequence, again, you could have the population becoming a mixture of parasite genotypes, and natural selection, therefore, at least potentially, can distinguish among those genotypes, such as in terms of within-host replication ability. You can also have the host simply not being as capable of holding back parasite replication. In this case, the parasite can display a greater level of virulence, not because it necessarily is any genetically different from other individuals infecting other hosts, but instead because the host itself is not able to hold back parasite replication. This doesn't necessarily give rise to the evolution of higher levels of parasite virulence. It's more equivalent to when you have phenotypic plasticity, the environment has changed, and therefore the phenotype, in this case, the replication ability or rate of the parasite or the virulence associated with the parasite has changed in going from a host that displays a greater level of immunity against the parasite to a host that displays less immunity. And then there are non-parasite factors that can result in a greater likelihood of parasite transmission. And recall from our just previous discussion, when there is a higher potential for parasite transmission, there may be less selection against expedients and therefore less selection against higher levels or displaying higher levels of virulence. So this is going to occur when host densities are higher. So this would be equivalent in the biofilm example of there being more surfaces to colonize. This may select for parasites that are able to replicate much faster and initiate transmission much faster so that their progeny can find their way to these readily available hosts to infect. And alternatively, novel routes of transmission may make hosts more available. An example of this could be the transmission of blood-borne pathogens via the sharing of needles when people are taking illicit drugs. Basically, the parasite no longer has to go through whatever steps it normally would have to go through in order to assure its transmission, because the transmission step is in fact potentially much less selective. So we'll get to this in a bit, but a sexually transmitted disease like HIV at a minimum requires that the individuals that are carrying the disease be sexually active in order to transmit the disease, which requires that the disease-causing organism not make their hosts too sick. But on the other hand, if the transmission is occurring simply by the sharing of needles, then the individual carrying the infection need only be sufficiently well to take an illicit drug and then share the needle in order for the parasite that's infecting it, in this case perhaps HIV, to be transmitted to a new individual.